Trigonometric leveling.
As for prerequisite information, do you know that trigonometric leveling involves measuring a vertical angle from a known distance with a theodolite? It is an instrument for measuring both horizontal and vertical angles. It consists of a telescope mounted movably within two perpendicular axes, the horizontal and vertical axes, and for computing the elevation of the point. With this method, vertical measurements can be made at the same time horizontal angles are measured for triangulation.
Objectives. First, to acquire and develop the skills of determining the vertical distance, elevation, and height of a remote point by applying trigonometric and related analysis. Second, to develop the skills of reading vertical angles using theodolite or total station. The materials used are theodolite, leveling rod, markers, chalk or marking pins, measuring tape, plumb bob, and range poles. Procedures. Trigonometric leveling.
First, set up the theodolite at a convenient location and call it point A, where the leveling rod and the remote point are visible. Second, using the telescope, take sight at the topmost remote point, then read the vertical angle and record as alpha on table 5 trigonometric leveling. Third, take another sight for the second triad. This is done to determine the position of the observations. Fourth, calculate the mean of the two vertical angles or the angle of elevation, which is not the zenith angle, of the specified point from the first station. Fifth, set the leveling stop or rod vertically near the base of the remote point and take the level foresight. For example, horizontal line or zero vertical angle on the rod to determine the height of the instrument. 6. Transfer the instrument level, which is the theodolite, towards the location of the remote point and designate it as station B. Then, measure its distance by taping from its initial position, which is station A. Record this as distance AB. 7. After centering the bubble of the instrument level, sight at the same topmost remote point or sighted before twice using the telescope and record as beta on table 5 trigonometric leveling. After recording these two observations of vertical angle, calculate the mean. 8. Level the telescope while at B and get the height of the instrument by sighting the same leveling rod near the base of the remote point. 9. Analyze. See figure below. The right triangles form to determine the height of the remote point. This fieldwork will not consider the effects of combined correction of Earth's curvature and refraction.
Analysis of the figure above. First, determine the difference in elevation between two instrument setups. Second, consider triangle B'EF, then solve for distance x using the tangent function. Determine the sum of distance AB and distance x for the analysis of the oblique triangle A'FD. Consider triangle A'FD and use sine law to determine the distance FD. Consider triangle FDG and determine the height of the remote point DG.
As for discussion and conclusion, breaking the tape method and measuring the horizontal distance of a sloping terrain have advantages and disadvantages. Its advantage is more accurate but also depends on the difficulty of the terrain. And as in odd, breaking the tape method is faster and less mathematical based data. Its disadvantages are breaking the tape method is hard when there is such a sloping in terrain or a substance that hindrances the straight path. In measuring the horizontal distance between 2 points, the most accurate is the measurement of the total distance system. We can also use the Pythagorean theorem in determining the angle. We can also use the law of cosines, law of sine, break the tape method, Abneyhan level, parallel distance measurement, and many other formulas.